Well, reciprocal functions. We're going to take a look at a couple of graphs of some reciprocal functions. And from the graph and both algebraically, we're going to identify the asymptotes and then determine what the domain and the range is of these two. We're going to look at two functions, these two functions. And so the first function is f of x equals 4 divided by x minus 3 minus 2. And let's, I think what we'll do is we'll take a look at the graph, which is over here on the right first. And I see that we've got a vertical asymptote where x is equal to 3. And here's my kind of my asymptote coming right there. And we see that our values of x don't ever equal 3. They're going to get really close to 3. In fact, it can be like 2.99 or 3.001, any of those things, but it will not equal 3, and therefore we got a vertical asymptote. Now, why is that? Well, that's because if I look at this denominator right here, where 4 is divided by x minus 3, that denominator cannot equal 0. And if I were to do this algebraically, I would say, well, x minus 3 is equal to 0. Set that denominator equal to 0 and solve. And so we're going to have a vertical asymptote at x equals 3. Now, what about our horizontal asymptote? Well, I can see here again, I've got a horizontal asymptote. It's going to be a little hard for me to draw on this computer. But right here where f of x or y is equal to negative 2, we've got a horizontal asymptote. Now, this is because we have a transformation here, and this transformation is created by this negative 2 or this minus 2 in this function, 4 divided by x minus 3, and then minus 2 or negative 2. And that gives us a translation, and in this case it's actually a vertical translation down 2, a vertical shift of down 2. And so that we could express in the, if we're just identifying the asymptote, we might say y or f of x, y equals f of x equals negative 2. We've got a horizontal asymptote at negative 2. We can see that graphically, and then we can look at the equation to determine that as well, that is in fact true. Now, as far as identifying the domain, well, the domain, the values of x can be anything but 3. And so we could say that the domain is equal to all values of x such that x does not equal 3. Any number but 3 is part of our domain. And what about our range? Well, same thing is true. Any values of y or f of x are in our range except negative 2. And so we could say that the range is equal to f of x. We could use y here if we wanted to rather than f of x, such that f of x does not equal negative 2. All right? So we've looked at it graphically. We've looked at it algebraically. Let's go look at another one. We got another function. G of x is equal to 2 divided by x plus 1 plus 5. And again, as far as my vertical asymptote, I'm just going to look at this denominator here. And we're going to set that denominator equal to 0. So x plus 1 equals 0. Solve for x. And so we've got a vertical asymptote where x equals, that should be negative 1. Negative 1. And then what about our horizontal asymptote? Well, without this transformation, this vertical translation of positive 5, actually our horizontal asymptote would be at 0. But since we got this plus 5 out here in this function equation, that again is a vertical shift up 5. And so we could say that, I'm going to use y this time, that y equals 5. Remember, f of x equals y, so I can use those interchangeably. if I want to. Now, so what would that mean about the domain? Well, the domain, then we could say any value of x except or such that x cannot equal -1. And our range, well, the same thing. We got this horizontal asymptote so that y such that y cannot equal 5. And if I look at the graph, we can see that that bears out. Here we got a vertical asymptote when x is equal to -1, and I can see that, drawing that asymptote in there. And what about my horizontal? Let's see, up 1, 2, 3, 4, 5. So I've got this horizontal asymptote running along here where y, or g of x in this case, equals 5. All right, so it's not too bad. You can look at it graphically, see it, but really you should I think, focus more so on the equation. Remember, it's in the denominator. The denominator cannot go to 0. When it does, if the denominator should equal 0, that's going to create the vertical asymptote. And then we see this transformation sitting out here, this +5, which gives us a shift, vertical shift, up or down, of the horizontal asymptote. So we're going to look at a little bit closer at a couple of other transformations of reciprocal functions in our next video. How about that?